Okay, this is the continuation and finalizing of the 1.1.6 lesson for simplifying radicals. We are multiplying two square roots, and what we're going to do is multiply the two radicands. Remember that the radicands is all of the information underneath the radicals. So I'm going to go ahead and multiply those together. So I'm going to end up with the square root, 7 times 42. That's going to be 294. And then x to the fifth times x to the, don't forget that it's an x to the first. We add their exponents. That will be x to the sixth. And then y to the ninth. All right, so now what I'm going to do is I'm almost going to look at this as two separate problems where I want to do the prime factorization and pull out any perfect squares factors of 294, and then I'm going to pull out any perfect squares that are variables. So 294, good news, it's an even number, so that breaks down as 2 times, and then we got to find out what's 294 divided by 2. 294 divided by 2 really quickly is 147. So then what I'm looking for is 147 a prime number, or does it have factors that we're aware of? So I start dividing by prime numbers that I know of, and right away when I did 147 divided by 3, I got 3 times 49. And I know that 49 is 7 times 7. So now I've written this as the product of all prime numbers, and the only pair, because our root is 2, understood root is 2, the only pair that is the same are these 7. So I know that the 7s get to come out, but these 2 and these 3 are going to have to stay in. So I'm going to leave a little bit of room for the 2 times 3, or 6, to stay underneath the radical. Next, I'm asking myself, okay, I need to, because writing the exponents as rational exponents, they would be the same as, say, x to the 6 over 2 and y to the 9 over 2, because it's power over root. So essentially you're dividing by whatever the root is. So what you're doing is you're almost dividing back before you understood about fractions when you were doing remainders, because that tells you what's able to come out and what has to stay in. So you're asking yourself, okay, how many times does 2 go into 6? And that's 3 times with a remainder of 0. So that means I could pull 3 of these x's out. And then I say, okay, how many times does 2 go into 9? And 2 times 4 is 8, with the remainder of 1 to get to 9. So 4 y's get to come out, and there was a remainder of 1, so that means 1 y had to stay in. And that's how we break down these type of radicals. Root example, and what I've already started with was the basic multiplication. We did the coefficients times the coefficients, and since we're working with 2 of the same root, we did radicand times radicand. I went ahead and added the exponents for the y's. 3 plus 4 is 7. So now I'm just going to do the multiplication. 3 times 2 is 6. And then I've got the cube root of 250 y to the 7th. And what I'm going to do is I'm just going to break down 250 and y to the 7th. Hopefully I can pull out some perfect cubes. All right, so that's going to be 5 times 50, 2 times 25, and 5 times 5. So now I'm looking for groups of 3. Well, there's a group of 3 right here with these 5s, and unfortunately that 2 doesn't have any group of 3 to go with, so it's got to stay underneath the radical. So I am going to be able to pull a 5 out to be multiplied by the 6 that's already on the outside of the radical. And then inside of my cube root, I have to leave this 2 that didn't have a group of 3 to be a part of. Next, I'm asking myself, since this is the root, I'm asking myself, how many times does 3 go into 7? And 3 goes into 7 twice with a remainder of 1. So that means that I have 2 y's coming out and 1 y remaining. And so finally, I simplify with 6 times 5 is 30, y squared, and then the cube root of 2y. This is how we would simplify a cube root radical. And what you're constantly looking for is ways to pull out, in this case, perfect cubes or cubic factors. In the previous example, it was pull out squares or perfect square factors. Notice that the group size is dictated by the root. So no matter what the problem is, that root tells you the group size before you can quote unquote pull it out of the radical to simplify.